BCS Embrace event for the year. Thank you very much for coming, each and every one of you. It's not an easy ask to ask members to come or individuals to come on a weekday to attend the event, but we do appreciate each and every one of you. Today's event is going to be called The Next Frontier, Quantum Computing and AI. Let's see, who do we have? This is here. So thank you very much for coming. We appreciate you all. Today's order of events will be to have a keynote speaker, then a panel conversation, then we end up with a 20-minute Q&A, inviting each and every one of you to comment, participate, ask those questions which you've had. And there is no silly question. Many of you probably have heard of this already. There is nothing like a silly question. We're all here to learn. And we understand that some people are experienced here, and feel free to share your knowledge as well later on during the Q&A. To start off, I'm going to introduce or highlight the key people involved today. So we're going to have Nzube Fodike, who is our current BCS Embrace outgoing chair, and who will be moderating the panel today. Then we have a lineup of speakers. We have Professor Simon Lucas, Professor of AI in the School of Electronic Engineering and Computer Science at the Queen Mary University, London. We have Wen Miao, co-founder and director of business development, Quantum Dice, and John Hammett, head of compute, Amazon Web Services, MIA, and Olu Odeniyi, co-founder, CXB. To kick us off, I would like to invite Professor Simon to give us a keynote speak on the topic. Professor Simon.
Let's check right here.
Not that there is a refreshments room next door. So, I'm only kidding. Might be in the gents or something. But in the meantime, welcome again. By a show of hands, while we've got some time, who already is in this space and doing stuff? I'm not talking about the keynote speakers and the speakers here, but who is already in this space and doing work in relation to AI? Would that be implementing or the user implementing stuff? Okay. And user.
It's on international standards, ISO 42001. It's an AI management system, AIMS.
And we know that's your forte. Fantastic. In terms of quantum computing, by show of hand, who's currently involved or is looking to journey into it? Journey into it? Okay. Doesn't know nothing about what's going on. I'm here to learn. Okay. Fantastic. Okay, so we've got a mixed crowd. Well, it looks and feels like there's a lot of explorers here looking to learn a bit more about what's going on in this space. So it's all exciting. So as I said earlier on, there are no silly questions. When you don't understand something later on, do ask. You're amongst friends and families here, so do feel free to talk. Everybody.
In Simon's absence, perhaps you can switch things around and have the panel first before Professor Simon.
Okay.
Starting to get hold of him.
All right, fantastic. These things happen when you're live. I'll tell you that. I'll make it up. Right, so in his absence, I'd like to invite the panel. So I'll start with Nzube, please. Come over. Wen Miao, please come over. John, please come over. The panel. And Olu, please come over to the panel. And I'll leave you in the capable hands of Nzube.
Brilliant. Thank you so much. And sorry about the bumpy start, but really good to be moderating this event. So Charlie did quick introductions earlier. I'm keen for you to perhaps share a little bit more about your professional backgrounds and journeys into your particular space. And if you can, within that introduction, just help set the scene with respect to some general definitions as you see within sort of quantum or AI respectively. So perhaps if we start with you first,
Right, happy to.
please.
Thank you for having me here. It's a pleasure to be on this panel. My name is Wen Miao, and as mentioned before, I'm one of the co-founders of Quantum Dice, which is a spin-out from the University of Oxford. And we are a product called a quantum number generator, and it's used for encrypting keys in both classical and also post-quantum methods of encryption, and also in simulations. Myself, my background is actually in chemistry, which I studied in my undergraduate. And how I entered the quantum sector was through a student startup program that the university ran. And that's where I met the rest of my co-founders, and I chose this particular technology to work on because I did a really interesting course in quantum mechanics back in my second year. And a lot of my work for the past 4 years has been focused on fundraising, as well as working with our tech team and also some of our customers, engineers, to help them understand what existing quantum technology capabilities are, and also how they can use our product in some of their systems.
Thank you. Hello.
Perfect, thank you. So I'm John Hammond. So I lead the compute business for EMEA for Amazon Web Services, which is pretty broad. That's everything from high performance computing over into EC2, and then some fun, slightly esoteric stuff. So the quantum business for Europe. My journey into all of this, I've loved IT since I was tiny. I grew up in a Kent estate in West London. Luckily got my hands on the BBC Micro when I was very young. Started coding as a 3-year-old, fell in love with the whole tech side of things. I'm extremely dyslexic, so I couldn't spell my name until I was 11, but managed to get an A at computer science when I was 13. Programmed Amiga game demos in Motorola 6800 for years, which turns out randomly is very similar to the things you need to know to build share trading systems. Then went on randomly, ended up being lead on the London Stock Exchange. Used to run trading systems for lots of banks, and then Accenture. And then so I was head of DevOps and full stack engineering for Accenture. So my interest within this, Aaron, I know we've been on panels before and talked before, actually, I think it's really interesting. Quantum is such an interesting area at the moment, and I think it's going through a real change. I think if I look back, the principles of quantum computing is something that's been going on for quite some time. And I think now the area itself is starting to separate into different subgenres. So you have quantum sensing coming on. I think we're seeing some really interesting things going through. You have, some of the usage coming into chemistry, and I think actually real usage of quantum machines are coming in very, very quickly. And you have some of the fantastic stuff that yourselves are doing with quantum random generators and quantum network. It's a big thing. And then on the AI side, I think AI is something that we as civilization tend to overestimate short-term impact and underestimate long-term impact. And I think that's exactly what we're doing at the moment. And for me, I want to try and see how we can basically bring something good.
Thank you, John.
Based on what John said, I grew up in East London. I got hold of a ZX Spectrum, which I programmed in BASIC until my brother sold it without me knowing. But I've always loved sort of tech as a child. I studied electronic systems engineering a very long time ago. Specialised in advanced computer engineering a very long time ago. In fact, I was just checking out some in my garage, and I came across my textbooks, which I find it very difficult to part with, even though they're way out of date probably. But so I spent time. I specialise in AI, cybersecurity, sort of digital transformation, helping organisations make the most of digital technology. And a lot of that, of course, is going and looking at AI. I taught on the advanced continuing education department or university and cybersecurity. I'm doing a bit of research at the University of West London. I'm on host-based AI and cybersecurity, which is quite interesting. And I teach some courses in the whole cybersecurity space, of which I've added in an AI flavour. And I'm quite passionate really about seeing where it's all going. I like to focus on the practical application of all of this. But I'm also a non-exec director for a couple of really large organisations, which takes me into governance space. And I speak on this topic, and I speak on data protection at times. And I remember speaking at Excel once. Some folks came up to me afterwards, lawyers, believe it or not. They said, yes, we're right in that situation you've just mentioned. Little AI project that was supposed to be just to see how it might work, suddenly becomes into production. There's no governance at all around it. And very often governance tries to catch up with actual world use. But I'm really excited about the whole area, and I read papers, stuff like that, you know, it's within line with what I do and always also further afield. That's a long introduction.
No, it's perfect. And actually, just while we're with you, Olu, just was curious, can you also share a little bit more about some of your views on what practical applications for AI can be rolled out today? And perhaps you as well, John, talking about us underestimating what we can do in the long time frame, and overestimating in the short term.
I mean, so I know that Professor Simon, when he comes here, he'll be his keynote, build large language models, etc., and so on. Who's using large language models? Any sort of using that on a regular basis? Okay. Who's programmatically using large language models, using the APIs into those? But that's where there's awesome power, and to automate the use of them, huge power indeed. Sure, you can go in and type and get your prompt engineer and go in and read all your prompt engineering books. But if you could programmatically use large language models, then it takes you on to a different level, and there's far more that you can do with it. And there's things before where you would have built an AI model, you've done some training, all that sort of thing. Sentiment analysis is a quick example. You can do that. You can do that with large language models by automating the API interface into it. In fact, I was at an expo. I like to go to expos, and I sometimes get invited to the after dinner drinks. I was coaching an individual who worked for a cybersecurity company. And he said, "Oh yes, this is what I do to try and work out whether this was a good or a bad signal." I said, "Do you realise you could do that programmatically?" So there's a lot I think for us to grow in that whole space programmatically. But John.
Yeah, no, I mean, I think it's such an interesting area at the moment. I mean, we're seeing it really permeate into everything. You know, there's been the interesting things happening with the large language. I mean, for me personally, completely transparent, large language models and how good they've got so quickly, it even took me by surprise. I kind of thought it was coming, but it's genuinely, it's been really interesting. I think so much of that is as a result of the underlying increase of data that we have. You know, the fundamental things there are there. The data is just scaled in a way that's easily accessible. And then fundamentally, Moore's law for now has continued to take on that scaling function, which kind of becomes interesting. I think in the long term, quantum definitely will have a case in that. In terms of the use cases that we see, our customers are using it for absolutely everything you can imagine. And that's from drug discovery to autonomous vehicle planning, where you try and use effectively a forward model to predict what's the best thing to do. One of the things that I would recommend people in this room to do, if you haven't tried it yet, is from a development perspective. There's different. I'm not here to sell anything Amazon-y, but you can use Amazon Code Whisperer, there's GitHub Copilot. It is genuinely quite amazing, I find, to have effectively a pair programming with an AI that can help. I think one of the interesting things that I think is going to happen. So I quite like chess. I quite like game theoretic things. I think they're really interesting expressions of reality with kind of limited subsets of rules, whereas we exist in a far more complex space, but there's similarities. I think it's really interesting when you look at you look back in the realms of history and you see Kasparov coming into it. People winning at chess for thousands of years. Kasparov comes in, Deep Blue beats him. You see chess robots getting better and better and better into AlphaZero, Stockfish, all the leading it. But if you look at now, what is the leading chess players on the planet, we're a really interesting situation where they're not purely chess robots, which I think is kind of beautiful. So there's a genre of chess called correspondence chess or mirror chess, where effectively you sit there and you have your human chess player and you have a machine that you work with. The idea is the human calculates the strategy and the chess robot calculates the tactics. And at the moment, those are the strongest chess players that exist. And I think actually, when I look at the broader concept of AI, that's where I see it going, at least for the next short, medium term, that people are going to get real advantage, the ones that use that combination of human and AI together. And I think you said one really interesting about APIs that I think I'd love to catch up with at some point and then get your view. I think the really interesting from an API perspective, where it's got very interesting is English is becoming the API, or natural language, I should say, sorry, is becoming the API. And actually going to a point that I can, almost, we released something called Party Rock, which is really interesting, which is the chaining of LLMs, where you're going to one LLM that effectively uses other LLMs via an API, but those sub requests are generated automatically, and it's absolutely fascinating. So, sorry, roundabout way.
And it's fascinating the progress that's happened. I graduated in computer science nearly 20 years ago, and my master's had a module on artificial intelligence. And to see what's happened back then, it was a very sub topic, but now it's obviously taken mainstream. And I'd like to get Chimera chess recommendations so I can become better when I play my opponents in chess. But coming to you in Mayo, I'm keen to get your view on a couple of things. So in layman's terms, because AI, large language model, ChatGPT is pretty much in the public domain, but quantum less so. So can you maybe share a little bit about what makes quantum computing so different from classical computing in terms of processing power and potential applications, as well as perhaps your view on timelines as to when quantum technologies would mature to be more commonplace?
Okay, yeah, for sure. So I think very similar to what John was mentioning earlier, I think within quantum technologies, there's three different types of branches of quantum technologies. And if you think about like a family, there's quantum computing, which is the youngest child that gets all the attention. And then there's quantum sensing and also quantum communications. And they all have very different timelines to when the technology will be mature enough to be deployed on like an enterprise level and to move out of academia. In terms of quantum computing, I think it's just has really significant advantages. So for example, for drug simulations or for molecular simulations, and from my chemistry background, I can definitely see the potential that could have even kind of for students that are doing their PhDs at universities and especially so for big farmers. But then coming a bit closer to home and coming back to what I work on a day-to-day basis, it's actually using the basic principles of quantum mechanics and putting that into a component level product, which kind of reduces the time that's needed for development. And it means that we are actually able to use and actually realize some of the benefits that quantum technologies could have in existing problems. And that's what I particularly like about the quantum random number generator component, because it's quite pervasive. So it can be used as a source of encryption keys for post-quantum security, like post-quantum cryptography or quantum key distribution. But these are avenues and areas that are still being developed by governments, large enterprises, and also universities now, and it will take years before they are realized and deployed into one commercial use. But quantum random number generators are also applicable in classical cryptography, and this is where we see a benefit to be, and this is why we spent a lot of time and also energy building our product and also our company around it. And the reason is because we've seen that the quality of the randomness actually do matter. And in the past 10 years, there have been multiple instances where the lower quality of the random numbers that's being used, so for example, they can be pseudo-random number generators from computer algorithms, or they can also be classical hardware-based random number generators, which are quite slow and also vulnerable to physical attacks. But we found that these existing solutions have certain drawbacks, which we're able to solve using so fundamentally realistic nature of mechanics to offer a true random number generator, but also to have a protocol that allows for hardware device monitoring, and this removes failure problem, and it's able, and it means that we're able to assure a lot of our customers and a lot of our users that whatever they are using as the encryption key is actually guaranteed to be truly random and also clean from that particular quantum source. And I think it's really exciting to be able to build a company in an industry like quantum technologies that's itself very nascent, and I think there's a lot of growth later on.
And another one for you, and also for the rest of the panel, just double clicking on that. So where does the border lie, in your opinion, between quantum enhanced AI and true artificial intelligence?
Well, I can say something.
Sure, please.
So the two currently your real academic papers on the two complementing each other, right? So, for example, the AI they'll use to try and get quantum algorithms can be used for quantum computers, and there's an expectation and belief, and it's very plausible that quantum computers will help speed up the training process, right? Especially on deep neural networks. So the two are there to potentially complement each other. And of course, there's a third aspect to that as well, in that that there's information currently which might be seen in what's called entanglement. All you QC guys out there will understand exactly what I'm talking about, which can see things which are being missed in the classic way that we currently train models. So there's a complementary thing going on there where they can actually each egg each other along.
So I suppose for me, interesting. One point I would definitely make around quantum computing at the moment is we are in early days, but that's it. But actually, some of these really interesting technologies you can go on and you can try now. So there are either via a number of different web providers. So us, Microsoft, IBM, you can go home and you can log on and you can run something in a quantum computer. And I know that's like a really minor thing, but if you imagine we were sitting back in the early days of ARPANET and the very early days of the internet, and someone turned around and said, "Yeah, you can just put this internet thing and give it a go." If you kind of look back now, even especially for your kids, you did it. I would just recommend everyone do that. And that sounds really well. And we provide a quantum machine learning library called Penny Lane that helps you with that, with this hybrid quantum machine learning. So that's one thing. In terms of crossover, so it's really interesting the things that you see in different bits of the market that I think will kind of come together. So when you look at quantum computing, one of the large problems around it is error correction. So there's errors. It's inherently simple. It's almost beautiful in its way that effectively the quantum state collapses when it's observed and it leaks out. It's beautiful from just a almost mathematical perspective. It's really interesting when you see how AI is changing error correction. And it's a slightly tangential area, but I don't know. Folk here probably take photos. I imagine some of you have SLRs, understand the concept of it. So effectively, you'll often pull photos off in RAW format, so RAW, and what it's doing is it's pulling the information straight off the CCD, puts it into a file, you post-process it to make your image. There ends up being errors in that, or noise that comes off from effectively heat on the sensor. All of these things are, and there's a really interesting company out there called DocSmart, nothing to do with us, just interesting for a thing. What they've done, effectively, they just provide raw post-processing. So they provide you import a raw file in and it creates a less noisy image. How have they done that? Well, they've literally taken thousands of digital cameras and a known, not input, but a known input, what it should. They've repeatedly taken photos of this input and they've trained a really large error correcting neural net. And that's one of the interesting things that I think is going to happen as AI goes forward and some of these models become more advanced. I think it will have really interesting inherent advantages in terms of the error correction that's possible with quantum computing. And so smaller, when you look originally, the size of a machine, the amount of qubits that you would need to provide some of this work, when you take error correction into account, I suspect, and my personal theory, is that through AI-based error correction, that number will start to go down. So I think you have this really interesting crossover. There's multiple other bits, but I just think it's such a fascinating bit from my side.
Just to add to that, a good example I see with the photographs is taking an out of focus photo and applying some of those softwares to produce a beautifully focused software.
Exactly. And I think that's one of the things. If you look at I always find it amazing that at any one time you can hold up your hand and put roughly a 50p, and that's the only thing that any of us can see at any one time. That is the only bit that your eye is able to keep in accurate focus. All the rest of it is a big neural net that's simulating that in the back. And I think this ability effectively to have noisy data sets or lower quality data sets, which I think some of the challenges you do get with some of the quantum sensing side of things, the ability to run that through AI, I think is just fascinating.
And the flip side of that is a really good example. The flip side of that, of course, is the old ethical side of it.
Yes.
And what is real? On what is it real?
Yeah, the BBC showed me a year or so ago that the US President of old Donald Trump was making a very, very positive speech in Chinese of the value of China. And they said, of course, number one, he doesn't speak Chinese. And number two, let's look around the mouth and you can see pixels. They shouldn't be there. It's a fake video.
Well, AI will, of course, 11 Labs. You might have heard of 11 Labs. The voice, they've just been, seen as a unicorn given the latest investment that's gone into them. And I've played around with it to an extent. I wouldn't put my voice in, but so it's another challenge and things, I think.
So do you want to add to that, or? Okay, so one final question from me, then we're going to get questions from the audience in person and online. So if you have any questions, get them ready. Simon Pick in the house, we'll have you at the end. We swap things around slightly. Thank you.
Appreciate it.
So
Simon now, so the questions can reflect what he's about to say.
I'm ready to go if you want me to do it now.
You ready to go?
Yeah, and by the way, I'm so ill, mate. I've never
It's
written a
fine.
keynote. I'm so
That's
good.
good.
It's fine. Okay, so perhaps you can just, do you need to get your
I've got
slides?
some
or-
slides with pretty pictures, so it'd be.
Let's jump out of the way and then we can, that makes
I
sense.
mean, I could do it from here.
But otherwise we just sit here.
Yeah,
and
yeah.
watch this.
I've got HDMI out on this.
So
So I
we'll
can.
switch to a 10-minute keynote with Professor Simon Lucas, and then we'll open up Q&A from the audience and from online. So if you have any questions, please get them ready. We'll be asking as soon as we finish the 10-minute keynote.
So can I plug in the HDMI from here?
Let me get IT support. One second.
Or I can send you, I can email whoever's presented here, I can email you the link to, they're on Google Slides, so I can do it that way too.
Might surprise you. It's an interesting thing.
What's your favorite?
All this technology, we've yet to sort out file transfer.
Battery's failing.
Effectively, you have.
Yeah.
You know who's
Oh,
on?
perfect.
Send a link.
You imagine every time you simulate. So simulate all you've got the model. You need two power. Simulate two.
We're gonna just talk through this.
Simulate a.
Sure, I'll do it. Yeah, yeah, okay. Okay, let's do it. So I did prepare some slides for this, and I've given the same sort of talk several times in recent weeks. Actually, I've been invited several times to give this type of talk. So the title of the talk is Making the Most of Generative AI. And if you could see the slides, you'd see that I've got lots of absolutely beautiful pop art pictures on them that I've used, of course, generative AI to create. And I think it's there's so many interesting issues around this area, right? So some people would say, well, that's kind of unethical because I should have employed an artist to produce these beautiful images, which you can't see. But you know, I would never have done that, right? So I think it's a really nice use of Gen AI to just make things better looking, to make us have more fun in what we do. So I've been using, I'm a professor of AI, right? And I've been at for many years. I do research in simulation-based AI, and this is really sort of a great way to make intelligent decisions really rapidly. And the idea is you have a simulation model of a system that you're trying to make decisions for. Games are a fantastic application of this. It's the same sort of technology that's behind things like AlphaGo. But you can apply it to any situation for which you have a good simulation. And so that's the kind of research thing that I do, and I still do that very actively. But you know, just over a year ago, something amazing happened, right? And ChatGPT landed. ChatGPT 3, I think it was at the time. And hands up if you use ChatGPT or a similar system basically every day. Yeah, so I reckon it's a majority of you, like 60% of you. And I think it's been a real game changer. So in addition to the kind of AI research I do, it's had a real big impact on the way I do my research, the way I do my education. And it's the same for a lot of people, right? And it's been such a shock. So at the time that this stuff was landed, I was a research scientist and software engineer at Meta. I was there on a 2-year secondment from my regular professor position. And these things were just landing, right? And we were saying, hang on a minute, with these coding models, so we're all software engineers, you know, we pride ourselves on our coding ability. And then we're thinking, hang on a minute, this thing is now pretty good at writing code, especially if it's kind of textbooky style code. And I don't mean things that are actually in a textbook. I mean the sort of things that have been covered a lot in textbooks, and things that are close to that. And as soon as you get more off the beaten path, then it becomes less good. But a lot of what we do as software engineers, right, is to kind of take a library that's already been written and adapt it to our current use case. And for that sort of thing, these systems are really incredible. And it's just been an absolute game changer for me in the way I do my research. So I think that whole sort of thing is fascinating. And people debate, will we still need software engineers in 5 years' time? And I sort of think and hope that we will. But it's going to change. It's already changing the nature of what we do. of how we execute our jobs. And in some ways, I think it's really making it much more pleasurable. So instead of getting stuck in all the kind of nitty gritty details of how to interface to a particular library, you can just say, this is what I want to do, and bang, the code is there. And it doesn't always work, right? But most of the time, 80% of the time, it does work if what you're doing is something fairly standard. And the other thing I'd say is, right, as software engineers, of course, we write great tests. And so one of the big problems that you normally have with things like ChatGPT, these large language models, is hallucination. And if you're trying to write an essay on something, it might be basically bullshitting you, right? And on closer analysis, you think, oh yeah, that's really not right. But as great software engineers, without great tests, we can take the generated software and put it through our test suite. And if it's passing all the tests, then that's a good indication that it's going to work. And of course, when humans write code, there are many errors in there. And so we need a robust testing process, whether we use an auto-generated code or not. So as an academic, part of what I do is I teach students. And before my secondment to Meta, I'd been head of school a couple of times and I hadn't done any teaching for a number of years already. So this year I've been teaching an undergraduate module in object-oriented programming, and that's been a real pleasure. And I've said to the students, we have this debate, right? So with generative AI, some people are very much, ostriches with their head stuck in the sand saying, this stuff, we don't really want to touch it. And we'll say to the students, you cannot use this. And we'll try and do all kind of plagiarism detection. That stuff's just nuts, right? You can't stop people using it. So the best thing to do, I think, is to kind of fully embrace it. And so I've been saying to the students for all the assignments, I said, you can use GitHub Copilot, you can use ChatGPT, Bard, fill your boots, do what you want. But what you have to do is you've got to come to the lab and to explain to us how it works. You've got to intellectually own what you've done. So you can use all these generative tools. And of course, many of them are going to get jobs as software engineers. And in industry, of course, you want to do things in the most efficient way you can. And most of the time, that's going to be using these amazing tools. Interestingly, I thought when I was doing things like preparing lecture notes for the course, that using these generative systems would save me time. And I don't think it saved me any time at all. But I do think it helped me to do a better job. And I think that's one of the really interesting reflections for me, is that quite often we go into these things saying, oh, yeah, I use this, it's going to save me time. What it does, sometimes it'll save me time. But what it does for me more often is make the whole job more pleasurable and more interesting, hopefully enabling us to do a better job. And it's just more sort of fun, compared to reading a textbook, having this interactive discussion is just so much more fun. Certainly for some like me, it is. I think the other thing I find really useful is when I'm writing lecture notes or giving a talk on something, I'll say to ChatGPT, because it's great now, you can upload PDFs, right? So you take a PDF of your slides and you upload it to ChatGPT and say, I'm giving a talk on this. What do you think of my slides? And what's always good, what I love about it, is it says, oh, they're great. The talk's going to be brilliant. It's so positive, so upbeat. But you might want to mention this, and it gives a couple of really good suggestions of things that you might want to add in. I think that was. I guess the other thing I think is interesting is in research there are so many applications of these generative technologies, right? And when it comes to authoring papers, different publication outlets have different policies which are evolving all the time. So some of them initially were trying to say, you can't use the outputs of LLMs in your paper. And now they're saying, well, a lot of the good ones are saying, you can use them with caution. You have to, intellectually own everything you do. It's your responsibility. Please tell us, and even put links to the chats that you had to help with the text. But I think one of the things that's really good, especially for non-native speakers of the language of the publication, which in scientific work is normally English, to be honest, to have the ability to put it through these systems to improve the quality of the text, I think is good for the writer and is good for the reader too, good for the reviewer. So one of the really interesting things that's come up is it okay to use it to help you do reviews? So as as academics, we have to run lots of reviews. Is it okay to use ChatGPT and so on to help you write the review. And I kind of leave that with the audience because I think we're probably out of time.
Thank you.
Okay, thank you.
The final set of questions, if you'd like to take a seat, please. Benma, Olu, we'll just go through the rest of the agile meeting. Okay, so thank you for bearing with us. So this final section, I had one question, but I'll just throw it open to the floor for now. Do we have any questions from members of the audience, online or here in person? So we have the judges. We'll take them in pairs. So if you wish to ask your question, please, your name, quick introduction and the question, and then we'll have you as well, please.
Sure. My name's Matt. I work for an IT consultancy, and this is particularly around cryptography and quantum computing. So obviously things like RSA are quite easy to break on quantum computers, and I know people are looking towards lattice encryption, but it's not there yet. So what's the solution for now?
And the second
answer.
question, okay, you wanna?
Yeah, just go back to where we were at the end of the chat previously.
Yeah.
It's actually in relation to AI and the upscaling and error correction on log files. It reminded me of an article I'd read yesterday saying the internet's considered potentially at 57% AI written and collated articles. With the internet being our kind of main source and primary source of information and data to work with, what do we make of this noise level, and have we got any plans in place to be able to overcome that or mitigate it?
The question on RSA cryptography and mitigating the noise. Would you like to go?
It's a cryptography thing. Have you seen the government, the NIST and the NCSC? Have you seen their answers to safe cryptography?
Not at the moment. A lot of the research I've done has been into lattice stuff, and it's coming, but it's not there.
They got some recommendations on this stuff. I actually listened to senior IBM quantum computing engineer who was speaking in this room, and I asked her that very same question, and she was quite passionate, as you could imagine, about computing. And she was saying, you know, it's well believed that nations are storing up information which they can break later on. So her advice was to switch over to quantum safe cryptography as soon as you're able. But of course, a lot of people in situ, you're the only one who isn't, think to themselves, well, you know, by the time it gets going, I'll be long retired.
Definitely on that point. There's a really interesting company, Arkit, British company, pulled out the SPAC specifically to quantum encryption. In terms of the working out whether people are doing it, it's very interesting. You can see on Google Maps some of the large data centers that have been built in the north of America, and you can roughly work out the power density of them because you can work out the size, work out the shape of Google Maps. And there's definitely very, very large storage data centers. The Americans are building that huge size. And you kind of start running the thought experiment through the cost of some of these data centers. And you're talking in the multiple billions. So America, for whatever reason, are storing multiple billions of dollars of data, which they're not necessarily processing, they're not putting back. So you kind of think, well, why would they be doing that? Well, the only reason they're doing it is because they can't currently de-encrypt it now, and they think they will. On the broader question, so I completely agree with you.
Yeah,
I'm glad someone else noticed that. Rather than me, I posted a slightly random article about it, and I couldn't tell anyone else had worked the same thing out. In terms of, do I worry about Shor's algorithm and it all being cracked? I think it will depend on the speed and the ability of quantum machines to come up. And actually, I think some of the error correction thing makes me suspect it might happen quicker than I thought. However, that being said, the upside around quantum chemistry is so unbelievably great. So I think, you know, I was talking to someone earlier, I mean, I think just really briefly, in terms of what is quantum computing, because I think it's a question that people sometimes don't realize that why does it matter, if that makes sense. If you think to take to simulate a quantum state, so let's say, for example, we want to try and simulate a single molecule, if that makes sense. So a single molecule is made out of multiple different quantum objects. So if we take penicillin, it's a relatively common molecule, as people would know. But to simulate one quantum state, so one quantum piece within it, so one electron from the spin, you need 2 to the power of 1. To simulate 2 to the power 2 to the power 3, 4. And so to simulate penicillin, you need 2 to the power of 176 bits. And that is a really, really, really big, like a hugely big number. And the whole advantage you get on quantum is every time you add a qubit onto it, you're able to have this exponential scaling that comes, or at least it will be as it comes through. So that's the background. So before it's all cracked, I'm kind of looking forward to my flying cars and carbon capture and really interesting stuff that's happened, which is I think with that sound.
And but the other bit to have on to that, it's not with quantum computing. You don't just sort of take classic data and then suddenly load it into a computer. There's initialization, and there's an initialization stage. So it's not that simple, and it might get that simple. But again,
and there's not exponential. I mean, it's in terms of, I mean, one of the things I'd love to pick some of the panel's brains, like, in terms of one of the things that really interests me, one of the things I think is a huge open question. A lot of people are talking about quantum machine learning and different kinds of pieces around that, or using quantum speed up. The reality is things like Shor's algorithm that has this exponential speed up, we can see in certain things. There is no machine learning algorithm at the moment that has it. That is, even if we had a really, really powerful quantum computer out there, that exponential speed up does not exist within the current, well, to my knowledge, does not exist within the current algorithmic space of it. I mean, in terms of the dead, not the dead internet theory, but the race, I think actually it's really, people have mixed views on Elon Musk for good reasons. But I think in terms of part of the way that there will have to be some kind of monetary tie to large data sets. I think that's the only way that you can do it. I think, you know, it is going to be interesting to see the amount of content created. I think the amount of like email, like, you know, everyone's had emails where they've been, you know, if you can tell it's not a prince that's trying to give me money, but going to a point where all of a sudden you have the ability to send out loads and loads of ultra targeted spear phishing emails, but at, you know, nation scale, it starts to get very, very problematic. And I think the only way of doing that will to be enforce some kind of tokenization to the underlying substrate of the whole thing, which is going to be an interesting change, I think. But I think it has to eventually.
But the other thing is, I read some stuff recently that suggested that humans were able to tell, that they felt they were able to tell what was generated by LLMs and what was not. It seems too flowery or whatever. So I think by augmenting it and doing as Professor Simon was saying earlier on, you sort of augmenting it and adding that human element into it. I mean, I've used it to generate content, and I thought that really isn't me, and I'm really not quite sure that, you know, that if someone met me, that they would actually be able to relate me to what
but I think you can ask them to generate in your particular style.
you can do.
So you can get large quantities of what you've written or indeed what you've spoken, and this sort of style
learns
is
it.
a real thing.
Yeah.
So also I would say that you know, these things are definitely getting better and better all the time on the whole.
One thing that I think is really interesting. So I also think history is fantastic to look at because it doesn't repeat, but it definitely rhymes. I think it's really interesting when you look at people talk about AI, people talk about artificial intelligence, as in the most intelligent thing that you should try and mimic is a human. And I think there's a weird, if you look back to where we thought our position in the universe was not that long ago, we thought the Earth was in the middle of the world, and, you know, everything else rotated around us. And then we suddenly realized actually that wasn't correct. There's heliocentricity. We all rotate around the sun. And I do sometimes wonder, actually, when I play with some of these LLMs doing different things, I feel like I'm playing with a different kind of intelligence.
Absolutely, absolutely. And in some ways, it's these things are already way more intelligent than people, right? You know, the access to vast knowledge that no single person can have.
Should we take a couple more questions? I'm keen to make sure everyone in the room has their questions asked. Vidya, please.
My name is Vijay Panchanathan. I work as a good governance implementer on international standards, using international standards. So do you think this marriage of quantum computing and AI coming together, do you see that it's more a philosophical question, I suppose? Do you see that go in terms of progression for humankind or regression for humankind going forward?
Existential question.
That's a really philosophical question, but I mean, I think it's right. I think it's one thing other panelists have talked about. It's new technology. It's a double-edged sword. There's good and the bad that comes along with it, and it's good that we are having conversations like we are today to discuss the benefits of chemistry and the applications in chemistry was. But then, of course, there's a risk that comes with national security. And I think the download now decrypt is a problem that you highlighted. That's also something that's quite critical. But I think from, I guess, as a startup and trying to work and trying to bring these types of scientific innovation into the market, what we find generally works really well for large enterprises is for them to each take quite an individual approach to adopting these new technologies. So going back to the earlier question, you know, what can companies do now to become quantum safe? One of the key things that I have seen being implemented is actually companies doing inventory exercises. So looking at the data that they have, looking at which segments of data they need longer term security for, and then really focusing their efforts on that particular segment, not really just doing it across the board, because at the moment it's just too time consuming and also very, very costly.
Yeah. Any final questions? I can ask my last question that I had before. So this is more about the applications, because I'm always keen to move beyond academia into the practical world. And I know you've done a lot of work and you've battled both, but in each of these views, can you talk about some of the most transformative possibilities that this combined technology holds for various sectors? And you've already touched on this, like healthcare, finance, and materials science. In any areas that people in here should probably pay a little bit more attention to? I'll start with you, Professor.
Yeah, thanks.
Yeah.
So I think one of the fantastic things now is that really anybody can have a go at writing software. So you can conceive of a wonderful application that you want, and you want to publish it as a mobile app or a website, and you could have a go at doing it. So, you know, we're at the BCS, right? So many of you already, you know, perhaps already write lots of software already, I'm not sure. But the idea is that anybody, you know, with a sufficient kind of motive and a bit of creativity can actually write software and deploy it and do really amazing things. It's a kind of democratization of software engineering. And you know, it's pretty variable at the moment, the results you get, but it's an amazing thing. And the other thing I would just quickly say is that if anyone's not yet using these systems, definitely it's worth doing it within your teams and talking to each other and just experimenting with it and keep trying and keep trying. And you will quite often see lots of articles about how ChatGPT said really something stupid, or Bard or Gemini, you know, had these ridiculous things. And yeah, it does do that sometimes, but you have to experiment with them and learn their kind of strengths and weaknesses.
Thank you.
And environmental is another area, of course, and you know, I mean, so we're sitting here, I'm almost boiling here, you know, but there are other places in the world that don't have heating and lighting, etc., and so on, and there are huge problems out there to be solved. I went a little some now and again I'll read something and I'll sort of focus on it a bit, and ended up reading a lot of sort of research in the whole, why can't we extract water from air, you know, and deliver it to the places that don't have water. And of course, there's lots of issues associated with that. Google did some interesting papers on that, and actually did a project. So I think in that whole space, there's lots of ways in which it can be used. But also, whilst we do, you know, live in this sort of comfy, more Western world, there are lots of issues that we have as well environmentally. So I think in the whole environmental space, just to choose a particular sector, there's lots of applications there.
John?
Yeah, I mean, for me, there's two in his list. I think it's lovely. It reminds me of Lotus's notes. If you're old enough to do that, effectively, for people that remember Lotus's notes, everyone used to be able to develop their own applications within it. I think that's something that actually the concept of the micro app being distributed into the enterprise is definitely coming back. In terms of you know, I think it's really interesting. So I'm a firm believer that we are in the midst of the fourth industrial revolution. So it's really interesting when you look at industrial revolutions, they tend to result as basically when a new general purpose technology comes up, when something comes up which doesn't necessarily have a use case built into it. Actually, those are some of the most important things. And I think this time it's going to be even more noticeable by the fact that we've got a number of very interesting general purpose technologies effectively landing at the same time. Key ones for me, I think quantum computing, from the stuff that it can do from a chemistry basis, I think is absolutely unbelievable. When I got really into this subject a number of years back now, it amazed me how little we understand about chemistry. We really don't. When you take everything from the invention of stainless steel that was just randomly picked out and chucked to, all of these things are just sheer luck to a large extent. And I think the ability for us to harness quantum to trade much larger data sets, I think, be really interesting. I think when you layer it with some of the, as weird as it sounds, I think some of the decreases in launch cost at the moment. So if you look at, I fancy doing some homework at home, it's really interesting seeing a combination of the amount of new satellites going up in combined with the decrease per kilo that's going into it. So you have this kind of interesting situation where very, very interesting new materials are being came up with that can do really strange, interesting things that can be produced at scale through a combination of quantum computing and then AI using that to effectively train forward things or remove the search space within it, combined with the ability to launch things, raw materials up effectively into a zero-G, effectively vacuum or very near to vacuum. It creates some really, really interesting possibilities as to where our future will look. I think that, and I think the final thing with AI, I think it's really interesting when you look at the underlying, or they've never made it public, so I can have theories, but so ChatGPT in itself is what's called an MOE model, so a mixture of experts. So actually, there's, I believe, six to eight, depending on you listen, different models behind that. What's really interesting is when you look at how, if we think this room, for example, the most intelligent thing in this room isn't any one person by a long, long way. It is the collection of this room, if that makes sense. And I think what's interesting about life, everything from trees to intelligence, it's these fractals coming down. So if you think of how intelligence evolves in your brain, there's really interesting research about that there's no me in here. There's no one single part. Actually, there's lots of individual bits with a voting network that goes part, which makes me together. If you look at society, what is the most intelligent thing I know of? It is human society, and effectively that's lots of independent people with independent bits going down, and effectively a distributed voting engine that comes up with the cost, which is capitalism. I think AI is going to get a lot smarter actually by moving into this distribute. You say you work with small models. I think that's one of the most interesting things around it. So going to this point effectively where we have lots and lots of smaller AI models with distributed voting systems that run over the top. I think there's some, in the short term, I think actually some of this starts to roll into production. I think some really, really interesting stuff that's going to happen to lots of stuff.
Yeah, just to add, they also end up creating new industries, like satellites are so cheap to launch, you create a future industry of managing space debris.
Well, I was thinking it's fascinating if you look at drones. So the only reason that we have drones is because we had mobile phones. So we had mobile phones and they used to all ring, if you remember that. They used to ring and it was really annoying because no one wanted the phone ring all the time. So people went, well, what we need is a vibrating alert. So all of this money went into effectively building smaller and smaller, it's a tiny motor with a little offset weight. And all the money that went into that, suddenly we had these small, lightweight, cheap motors that could be put into things. And that created this whole drone revolution. And I think it's almost law of unintended consequences that come up as we go through this that I'm genuinely excited about.
No, I think there's definitely a plethora of things to be excited about. And I think it's just really fortunate that I guess quantum technologies and also AI are two underpinning technologies that cuts across a lot of